we said that there ISIS has a 2-layer hierarchy, level 1 routers and level 2 routers. Level 1 forms the main backbone, level 2 is your backbone. And there are 3 router roles, level 1 routers which establish adjacencies with either level 1 or level 1 to routers, and level 1 routers basically provide intra-area routing. The other router role is level 2 routers, which can establish adjacencies with the other level 2 or level 1, level 2 routers. So these provide the backbone function. You also have level 1, level 2 routers that are used for intra-area routing. So they have one leg falling in level 1 and a second leg falling in level 2 in the backbone. So most vendors now default to level 1, level 2, and the network engineer is required to decide which level they want to run their routers, whether level 1 or level 2. So if you want to run your routers in level 2, you turn off level 1. If you want level 1, you turn off level 2. Otherwise, by default, the router will be a level 1, level 2 router. So those are the 2 levels in ISIS. The other key thing we have to take note of is ISIS areas. As you know, in OSPF, a router's interface is assigned to a particular area. So if you have a router with 3 interfaces, for example, you have interface 1 residing in area 0, which is the backbone for OSPF. You can have area 2 in area 1, rather interface 2 in area 1 and interface 3 in area 3. Now, the concept of areas in ISIS is different. In ISIS, we have the entire router sitting in an area, not just an interface of the router, but the entire intermediate system sits in an area. So in production, you'll find that in most cases, you have only one area defined on an intermediate system or a router, but it's also possible to have more than one area at a time on a router. ISIS does not have a backbone area. The backbone is formed by a string of level 2 routers. Remember, in OSPF, there is need for the area 0, which forms the backbone. Again, in ISIS, the area affects formation of adjacencies between 2 routers. And the level controls the flooding scope of LSPs. So there are mainly 2 functions of the area. Remember, in OSPF, the area defines the flooding scope of the LSAs, link state advertisements. But in ISIS, it's done by the level. It's the level that controls the flooding scope of link state PDUs. So the 2 functions, main functions of the area, one are to define the formation of adjacencies, and secondly, to define the generation of the default route, as we shall see. So we know the different levels of ISIS. We know the concept of ISIS areas. Now we want to see formation of adjacencies. What happens if we have the same area and have a combination of different levels of routers in that area? So in this example, we have area 0, and we want to have a combination of different levels within that area and see if an adjacency comes up. If it does, what type of adjacency do we get? So we have a level 1. I hope you can see my cursor.
I can see.
Yes, so in this picture here, we do have router 1 and router 2 in area 0. Router 1 and router 2 are both level 1. So since they're in the same area, they'll form a level 1 adjacency. Okay. The next diagram has router 7 and router 8. They are both level 2 routers and they are in the same area, so they form a level 2 adjacency. We have a level 1 and a level 2 router in the same area. Because the levels don't match, there won't be any adjacency formed. We do have a level 2 and a level 1, 2 router in area 20. The matching levels are level 2, so we shall have a level 2 adjacency. If we have a level 1 and a level 1, 2 in the same area, the matching levels are level 1, so we shall have a level 1 adjacency. If we have a level 1, 2 connected to a level 1, 2 in the same area, the matching levels are level 1 and level 2. So we shall have a level 1, level 2 adjacency. So the key thing to take away from here is that for routers to form an IS-IS adjacency, the levels should match. If the levels don't match, there won't be an adjacency. And the other thing is that level 1 routers can only form an adjacency if they are within the same area. Okay. So here is another example, but this time looking at adjacencies in different areas. So we have area 20 and area 30. We have a level 1 router in area 20 and a level 1 router in area 30. Because they are in different areas, they shall not form an adjacency. Okay. We have a level 1 router and a level 2 router in different areas. Because the levels don't match and they are in different areas, there shall not be any adjacency formed. And again, remember that for a level 1 router to form an adjacency, it should be in the same area with a remote intermediate system. So we don't expect these level 1 routers to form any IS-IS adjacency with whichever level of a router. So here we have a level 2 router connected to a level 2 router. They are both in different areas, area 20 and area 20. They are in different areas, and we know that level 2 routers are backbone routers, so they can form adjacencies across areas. And the matching level here is level 2, so we shall have a level 2 adjacency. Level 2 connected to a level 1, 2 in different areas. The matching level is level 2, so we shall have just one adjacency, a level 2 adjacency. A level 1, 2 connected to a level 1, 2 in different areas, we shall have only a level 2 adjacency. So the key thing to take away from here is that between areas, you can only form a level 2 adjacency. You cannot have a level 1 adjacency. Okay, and the routers that can do that are either level 1 routers or level 1, 2 routers. So we can expand our diagram to show the adjacencies between different areas, okay, and the backbone area. So in this case, we have 3 areas, area 1, area 2, and area 3. Area 1 has router R1 and R2. R1 is a level 1 router, R2 is a level 1, 2 router. Remember, this is our area border router. So if you want to connect to another area, if you have level 1 routers in a given area and you want to connect to another area, the router or intermediate system at the border that enables that interconnection is a level 1 2 router. So we have area 1 with the level 1 and level 1, 2 router. And then in area 2, we have 2 level 2 routers forming the backbone. Yes, so another key thing to notice here is that the backbone area is any random area. It doesn't have to be area 0 as for SPF. So in this case, we're using area 2. We have area 3 with, again, 2 routers, router 5 and router 6, which are level 1, 2 and level 1. So this level 1 router can talk to level 1 routers within the same area. We've talked about this. If you want to go out of the router, you have to use a level 1, 2 router and a level 1, 2 router, or a level 2 and a level 2. So in this case, we have a level 1 router and a level 2 router. So these level 2 routers in area 2 can talk to level 2 routers within the backbone. They can also talk to level 1, 2 routers that are area border routers in an area that has level 1 routers. Okay. So if we have, for example, a subnet in area 3, a subnet 203.0.113.0/24, and another subnet 100.104.128.0/24 in area 2 in the backbone area. The default behavior of level 1 routers is that they won't learn about external prefixes by default. in ISIS. Remember, in OSPF, the area border router will leak external routes into the non-backbone areas. So you can either decide to have your OSPF areas as not so stubby areas, or stub areas, or totally stubby areas, whichever flavor you may choose. But in ISIS, by default, the level 1, 2 routers do not advertise external routes to level 1 routers. So in such a scenario, if you have such a design in your network, how do level 1 routers learn about or get to 100 external prefixes like 100.100, 100.104 or 203.0 prefixes? So the feature that enables this reachability is something known as the attached bit. So in this case, we have router R2, which is a level 1, 2 router connected to area 2. So the moment this level 1, 2 router is connected to a different area, it will generate what is known as an attached bit in its level 1 LSP. We are going to talk about LSPs. So it generates that in the LSP and sends it over to the level 1 routers. So once a level 1 router sees the attached bit in the LSP, it generates a default route that points to the level 1, 2 router. So that way it is able to go out of its area. Okay. So the other method that you can use if you don't want to use the attached bit is to write policies, the distribution policies from level 2 into level 1. Okay. So now the next thing is to talk about the network types that are available in ISIS. There are basically 2 network types. There is the broadcast network type and the point-to-point network type. The broadcast network type is the default type, and it's mainly used on multi-access interfaces like Ethernet. And on these broadcast interfaces, a DIS, or a designated intermediate system, is elected based on interface priority, whichever is highest. If there is a tie in the interface priority, the SNPA or subnetwork point of attachment, which is another way of saying MAC addresses. If there's a tie in the priority, the SNPA is considered. Whichever is highest is taken as the DIS. So the purpose of the designated intermediate system, or the DIS, is basically to flood LSPs to the other intermediate systems that are attached to that broadcast network. So the DIS is similar to the designated router in OSPF, but as you know, in OSPF, there is always a designated router and a backup designated router. In ISIS, there is no such thing as a backup DIS. And the other thing is that election of the DIS in ISIS is preemptive. So if you have elected a DIS on your broadcast link, if a new intermediate system or a new router joins the LAN, and that router happens to have a high priority, then that will take over the role of the DIS. Remember, in OSPF, the designated router is sticky. Once a router has taken the role of being a designated router, it will be a designated router until it goes down. Then a new DR will be elected. The second network type is point-to-point. And this is used in cases where you have 2 routers connected in a point-to-point fashion. It can be on serial interfaces or Ethernet links. It doesn't matter, provided you have 2 routers connected. And for this network type, you do not need to elect a DIS. It's not required, and it's not elected. The LSPs, level 1 and level 2 LSPs, are sent directly to the neighbor. And of course, those are actually using PSNPs. We are going to talk about those different packet types in ISIS. So the point-to-point network type is the recommended network type by the different vendors, Cisco and Juniper and any other vendors, provided that you have 2 routers connected in point-to-point fashion. You enable the point-to-point network type. Otherwise, if you don't, the network type will default to broadcast, and therefore you have a DIS selected, yet the DIS is not required on the point-to-point link. All right, so we've we've seen some indications, or we've talked about LSPs and PSNPs in the previous slides. We would like to know the different meanings of these packet types. So in ISIS, there are basically three categories of protocol data units. And these are the ISIS Hello PDU, which is abbreviated as IIH. The second one is the link state PDU, which is abbreviated as LSP. And like I said, please don't confuse these acronyms. LSP, depending on the context, it could be referring to link state PDUs or label switch path in MPLS. So the third category is the sequence number PDU, SNP. And of course, that is also broken down into a complete sequence number PDU, CSNP, or a partial sequence number PDU, PSNP. So the role of the ISIS Hello PDU is just to establish adjacencies and maintain adjacencies. That is the main function of the ISIS Hello PDU. And there are mainly three subcategories of this type of PDU. There is a point-to-point ISIS Hello PDU that is used on point-to-point links. And if you have a broadcast network, then there are two Hello PDUs that you'll find on that broadcast network. You have a level 1. In case the routers are level 1, they'll send level 1 LAN ISIS Hello PDUs. If the routers are level 2, they'll send or exchange level 2 LAN ISIS Hello PDUs. If it's level 1, level 2 routers connected on a broadcast network, they'll send both level 1 and level 2 ISIS Hello PDUs. So this is the PDU that is used to elect a DIS in a broadcast network. So you know what a DIS is. So the second type of link state PDU is the second type of ISIS PDU is the link state PDU. Once you formed your adjacency, the next thing is to share routing information. And that is done using link state PDUs. Okay, all they do is to carry link state information. And of course, the link state information that we're talking about here are the different adjacencies, the connected interfaces, connected and advertised in ISIS, the metrics that are associated with those connected interfaces, and any such information that is to do with link state information in particular intermediate system. So each intermediate system generates an LSP for itself. If you have a router 1, router A, router B, router C, each of those routers will generate LSPs for themselves. So you have LSP, an LSP for router 1, router A, an LSP for router B, an LSP for router C. So once the routers have generated LSPs, they flood these LSPs throughout the network. And of course, we've talked about the different levels in ISIS. So we have two types of LSPs, level 1 LSPs that are generated and set by level 1 routers. Then we also have level 2 LSPs. These are sent by level 2 routers. So if you have a level 1, level 2 router, it will send both types of LSPs. Now, once LSPs are flooded throughout the network, the intermediate system or the routers will store these LSPs in what is known as a link state database. Okay, so you'll have a link state database for level 1 and a link state database for level 2. If you have a level 1, level 2 router, it will have both link state databases. So the information that is contained in LSPs, like we've said, you have neighbors, adjacent neighbors, you have prefixes of directly connected networks. These are the links that are directly connected to that particular intermediate system. But it's not enough to have a link directly connected. It has to be advertised in ISIS. Okay. And the third piece of information that you find in the LSP is the metric associated with that interface. Okay, and each LSP will have a sequencing number that increases whenever there is a change in the LSP. So these changes in LSPs could be maybe a change in the metric or a change in the mask and so on. The third ISIS packet type is the sequence number PDU. Okay, and the main function of the sequence number PDU really is just to synchronize the databases, to make sure that all routers within a given level have the same view of the network topology. Okay, and there are two types of sequence number PDUs. You have the complete sequence number PDU and the partial sequence number PDU. So the CSNP, it's complete. It gives you a complete view of the topology. So it will send a list of all LSPs that are available in the link state database. Okay. So on broadcast networks, you'll have the CSNP set by the DIS, while on point-to-point networks, the CSNP is sent by the adjacent routers. Okay. And another key thing to note is that on point-to-point networks, the CSNP is only sent during establishment of an adjacency, while in broadcast networks, it's sent periodically by the designated intermediate system. The other type of sequence number PDU is the PSNP, the partial sequence number PDU. And this is used to request one or more LSPs and to acknowledge receipt of LSPs. So in the development of ISIS, remember initially we said that ISIS was originally developed by people at Digital Equipment Corporation in the US, and their original definition of ISIS, the protocol, was for CLNS. Okay, they were not thinking about IP. But because IP was the most popular layer 3 protocol, then they had to extend ISIS to support IP. And that was done through the use of TLVs. So the main function of TLVs, or type length values, is to enhance ISIS. Okay. So the very first enhancement that came through TLVs was the addition of IP to ISIS. But there are several other TLVs that are used to add extra features to ISIS. You have the area TLV, padding TLV, protocol supported TLV, authentication TLV, and so many other TLVs. Okay. So again, we said that ISIS was originally developed for CLNS. And in CLNS, we have something called the NSAP address that defines an entity, that defines a router or an intermediate system. Okay, so in routing or in ISIS, we have something called the network entity title, which is a unique identifier for an intermediate system. And this address is configured manually on the router. Okay, you'll find that in other routing protocols like OSPF, you have an IP that is used as a router ID. But for ISIS, we use a network entity title. So the NET has a very interesting structure. We have IDP. In a general sense, we have two parts that are forming the network entity title. We have the IDP, which is the initial domain part, and the DSP, which is the domain specific part. So the AFI is the authority and format identifier, of course, which mainly just defines the authority that is dishing out this NET to whoever is going to use the NET. We have a system ID, which is a local setting that defines the local router itself, and the network selector, which is always 0 for a router. So here we have an example of an NET 49.001, where 49 is the AFI, okay, which is the private number. 49 is a private AFI. And 001 is the area. We have the system ID, and the last two zeros at the end are the network selector. Okay, so ISIS has generally 4 metric values. We have the default metric, the delay metric, expense metric, and the error metric. But I think in earlier versions of Cisco iOS and Junos, the only supported metric was the default metric. I understand in more recent code of Cisco iOS and Junos, there is support for other metrics like the delay metric, expense, and error metric. Okay, and so the default metric in both Cisco and Junos is 10, regardless of the type of the interface. If it's serial or a GE interface or a 10GE interface or 20GE or whatever, the default metric is always 10, but this is configurable. You can always change it. Okay. So the other thing is that by default, these routers will come up with narrow metrics, both iOS and Junos. So you'll have to manually change the metric from narrow to wide metrics. The narrow metrics have a maximum of 63 on an interface, and you can only have a maximum of 1023 per path in the routing table. Okay, so the best practice when configuring ISIS is to enable wide metrics. So it will increase the maximum metric to that value. And another key thing to note is that, for example, if you have, okay, in small networks, this might not be a challenge, okay, but if you have so many links that are forming the backbone, then you can easily go beyond the set maximum per path. Therefore, such routes will not be reachable. So it's important that you enable wide metrics when configuring ISIS. So let's talk about IP version 6 in ISIS. So when you are enabling IPv6 in your ISIS implementation, you have to take note that there are mainly two flavors of using ISIS. You can either have a single topology ISIS or multi-topology ISIS. So in single topology ISIS, the concept is that the only one SPF calculation is done to create the topology of the network. So that means that all your interfaces must have both IPv4 and IP version 6. If you don't have IPv6 on any of your interfaces, this will black hole your IPv6 traffic, okay? Because you have one SPF calculation. If you want to avoid that, you enable multi-topology, the multi-topology feature, which allows you to have two computations of the SPF. You have the IPv4 SPF and the IPv6 SPF. So that way you can have different trees for each of these address families. Okay. So
there's a question from Ramadan.
Okay. Sorry, I want to know how does the formation. Okay, so there's a question from Ramadan. He's saying, I want to know how the default metric works and the importance of expanding it from the default metric. Okay, so the default metric, like we said, is 10 on Juniper and Cisco. Okay, so regardless of the network, regardless of the interface type, whether you have an FE interface or a serial interface, if you're a network that has SDH, or you have G interface or 10G, it doesn't matter. The default metric will always be 10. However, if you want to do, for example, traffic engineering based on IGP, on your IGP on ISIS, the maximum you can go is 1023. Okay. That's the maximum you can go, meaning that if a path has a metric that goes beyond 1023, it will be flagged as an invalid route. It will be flagged as an unreachable route. So by enabling wide metrics, you increase the default metric to a high value that you can play around with. And the example that I'm giving here is doing traffic engineering based on your IGP. And the other thing is we've talked about single and multi-topology. We've talked about single and multi-topology and seen the benefit. I think we are getting...
Ramadan, your mic is open. Could you mute? And also at the same time, Wilson is responding to your question. So I'm not sure you...
Okay, so there's another question here from Olivia. Olivia is asked, and this is related to what I wanted to talk about. Olivia is asking, what happens if you don't specify the wide matrix? Will the interface be restricted to a particular metric, or if we just consider? So the interface will be restricted to narrow metrics if you don't specify the wide matrix. I understand that in the recent versions, actually wide metrics are by default, narrow and wide metrics are by default enabled. We shall see that in the practical labs. But in earlier versions of Cisco iOS and Junos, they came up with only narrow metrics. Okay, so I wanted to take us back to the concept of the single and multi-topology in for IP version 6. And we know the benefit of multi-topology. Okay, now for you to enable multi-topology on your router, you should have wide matrix enabled, because multi-topology ISI, so IP version 6 works with wide matrix, not narrow matrix. Okay. All right. So here is a configuration example for Junos. This is how you set up ISIS. So what you basically do after you've configured your IP version 4 and IP version 6, the key thing that you need to enable here is the network entity title. Okay.
So Wilson, there's a question from Ibrahim. What happens if I go with the default value? So what happens is the adjacencies will form, and so you will not be able to use the IGP to do traffic engineering unless, for example, if you have 3 routers, you know, you might have a direct route and less direct route that goes through 2 routers. The cost in that case will be 20 through the 2 routers. The direct one will be 10, and traffic will follow the direct route that has 20. So you have to look at the cost of the destinations where you want the traffic to end up. And you modify the metrics to kind of bias where the traffic is going to pass. So if you have a total route of 20 or 30 on one route and another route that has 10, then traffic will follow within your network. Remember, this is an IGP. Traffic will follow the path with the smaller total metric.
Sure.
I hope that answers your question, Ibar.
All right. Thanks, Joe. Thanks, Joe, for that. I think that's clear. Yes. Yes, Joe. Go on.
Ibar, is that okay? Okay. Says thanks.
All right. Okay. Yeah. So this is a sample configuration of ISIS on Junos. So we have a loopback interface now with IPv4 and IP version 6, and we've set up the network entity type. The NET can go on any interface, but it's recommended or preferred to do it on a loopback interface, because remember, loopback interfaces are always up. Provided the router is up, the loopback interface will be up. If you configure it on a physical interface, that interface will go down. Maybe if there's nothing connected to it, or maybe the line card is faulty, or for any other reason, it can go down. However, the loopback interface will be up, provided the box is up. So it's always recommended or preferred to configure your NET on a loopback interface. Okay. Then once you've configured the NET, remember you have to specify the ISO address family here. You go to the interfaces where you want to form adjacencies. Okay. And then enable family ISO. Under those specific interfaces, if you don't enable family ISO, this is how you enable ISIS on the interface. By default, in Junos, interfaces will only accept IP traffic. They do not accept ISIS traffic. So for you to tell these interfaces to start taking in ISIS traffic, you have to add the family ISO on the interface. So once you've done the interface configurations, set the NET on the loopback and enabled family eyes on your interfaces where you want to form adjacencies. The next thing is to go under the protocol and enable these key things that we've talked about. Multi-topology for IP version 6 and the wide matrix. Okay, we know the benefit of using wide matrix on your network. Then the other thing that you'll notice here is that we've specified the network type as point-to-point because we have only 2 routers connected on this link. There is no need of electing a DIS on the link. So we hard code the network type to point-to-point for all interfaces. Okay, and because we don't want to form an adjacency on the loopback interface, we set it as a passive interface in the configuration. So those are 3 things that you need to do. Go to the loopback interface, set the NET, go to your physical interfaces where you want to form adjacencies and enable family ISO, telling the interface to start receiving IS traffic. Then go in under your protocols IS, enable multi-topology, turn on wide matrix, and then set the network type to point-to-point. Now, if you're setting up a backbone, we've said that in ISPs, the backbone is really just level 2 routers. There's no need of having level 1 routers. So you can disable level 1 on your interfaces and only have level 2. Also, by default, the default metric is 10, but it's also good practice to hard code the metric. Okay, such that when you're looking through the configurations, you can easily tell what the metric is for a given interface. Then for iOS XE, which is Cisco, for you to set up ISIS, what you do, you start the ISIS process. AS64496 is just a process name. It can be anything. Okay. Then under the process, you define the NET, hard code the IS type, which defines the level. We are working with a backbone here, so we shall have level 2 routers only. Enable wide matrix, and then set your loopback as a passive interface in ISIS because you don't want to set, enable adjacencies. You don't want to have adjacencies on your loopback. Okay, so you had code that as a passive interface under the ISIS process. Okay, then set enable multipology ISIS under address family IP version 6. So that is what you have to do basically. Okay, to have your ISIS up and running. There are so many other things that you can add, but basic setup is that is sufficient. So once you've configured the process, ISIS process, you go to your interface where you want to have ISIS adjacencies, and then turn on ISIS for both address families for IPv4 and IP version 6. So we have an ISIS process of AS64496. So under your interface, you say IP router ISIS, the process that you've configured. You do the same thing for IP version 6. So that turns on ISIS for both IP version 4 and IP version 6. The other thing is to hard code your network type to point-to-point, because this is a backbone. You have only 2 routers connected. No need of having a broadcast network type. So you hard code it to point-to-point. And another key thing that I should mention here is that the network type should match. If you have 2 routers connected, and one router has a point-to-point network type, while the other router has a broadcast network type, the adjacency can't come up, it won't come up. So until you match the network types, that's when the adjacency will come up. So it's important that you take note of such small mistakes when configuring ISIS. So in practice, where does this IGP?
Sorry, Wilson.
Yes, please.
I have a question.
Yes.
What if in my configuration I did not specify the level?
Pardon?
In my configuration, what if I want to specify IS type level? What will happen?
If you do not specify the level, it will default to level 1, level 2.
Okay.
Yes, by default. So meaning you'll have 2 LSDBs. You have a level 1 link state database and a level 2 link state database. But if you're working with a backbone area, there's really no need of you carrying the level 1 database. You're better off turning it off and carrying just the level 2 LSDB.
Thank you.
Yes.
And if I went on the previous slides, we have seen level 1, level 2, and level 1, level 2, level 2. By default, it will select, right, according to the end device, the level that is lining, right? Yeah. So how can it automatically adjust according to the endpoint level?
So you want this to auto detect the level of the remote of the adjacent neighbor.
Yeah.
So by it can't detect it automatically. It can through the hello PDUs, and if it notices that there is a mismatch in the levels, the adjacency does not come up. Okay, so you have to tell the router which level you want it to operate in. If you do not tell it, it will default to level 1, level 2.
I think what he's asking is if you have two routers with default, let's say you haven't specified the level, so you have level 1, level 2, and another router level 1, level 2. What kind of adjacency they are going to form because they're going to be sending level 1, level 2 LSPs.
Sure. So in that case, they will form both adjacencies, level 1 and level 2 adjacency.
So the general practice, and this is something Wilson and I advocate on the network, is to keep the network as simple as possible. So for you to be able to troubleshoot problems on your network, you need to be able to interpret what you see, the messages you're seeing on the router, and therefore it's best practice to keep the network as simple as possible. If you have a backbone router, specify the router to be level 2. That way, when you go to check what is wrong with the network, then the messages will start making sense. Because if you have information about level 1 adjacency and level 2 adjacency on the same screen, you might not be able to tell what is happening. My advice to you is to keep the network as simple as possible. And that is why we advise you to use ISIS, because it makes things quite simple.
Sure. Yeah, please keep your networks as simple as possible. So turn off any unnecessary features that you really don't need. So if you know you don't need level 1 on your backbone, explicitly turn it off and work with level 2.
Yes. Oh, thank you.
Okay.
Just for information, the network that we run has, I think, up to 14 routers now. We only have them all on level 2. We don't run a multi-area network. It's just we string the routers up, connect, and they form the adjacencies, and we've not had any problem.
Sure. Thanks, Joe. All right. Yeah. So if you're running, if you have a dual stack network, meaning you have IPv4 and IP version 6, I think in ISIS would be really easy to roll out compared to OSPF, because in OSPF you'll have to have another process. You'll have to run OSPF version 3. Okay, but in ISIS you can have a dual stack network defined under the same process. Again, like we said, that the most popular IGP in service provider environments is ISIS. Yes, there are service providers that use OSPF, but if you look at the statistics, the most popular IGP that you find in service provider environments is ISIS. So they use it as an underlay to their BGP and MPLS networks. It actually makes it easy to work with things like MPLS traffic engineering and so on. All right, so in conclusion.
Sorry, just before you conclude, may I ask people to send on the chat whether they are running IPv4 and IPv6 together or IPv4 only? Just specify your NREN and tell us whether you're running both IPv4 and 6 or you're just running IPv4. Thank you.
Okay. Yeah, thanks, Joe. So in conclusion, please enable IP version 6. We all know that IPv4 is running out. It has run out in some parts of the world, and I think it's just Africa where we still have some IPv4 left for allocation. So please, if you have IP version 6, deploy it and use it. If you don't have IP version 6, you can put in an application, submit an application to Afrinic to be allocated IP version 6 and roll it out. Work with it on your backbone. Hard code, wide matrix, enable wide matrix. You'll need it. Enable the multi-topology for IP version 6. Always hard code your interface matrix. Even if we know that the default is 10, you can still work with the defaults, but it's good practice to set your interface matrix. Disable level 1 on your backbone because you really do not need it. Okay, and like Joe said, for you to make your life easy when troubleshooting these things, you don't want unnecessary information popping up on the CLI when troubleshooting or trying to check why an adjacency is not coming up or a prefix is unreachable and so on. And again, when you making a plan for your NETs, the network entity title, it is good to derive the system IDs from your loopback because it makes your network simple. You can easily identify messages when you have your system ID mapped to a loopback. Okay, and lastly, the MTU of the point-to-point links, your backbone links, should always be greater than 1500. It is good practice to have jumbo frames enabled on your links and to make sure that the provider of your links supports these big packets. Okay, because like we said in the TLVs, there's a padding TLV that is used to check mismatches in MTU. If you have one end with an MTU of 1500, another end with an MTU of 9000, the adjacency won't come up. Or if you've set your MTU to say 9000 and your provider, the provider of your backbone link, does not support that MTU, the adjacency won't come up. So the use of the padding TLV is really to detect mismatches, okay, such that the adjacency does not come up because of underlying issues on the transmission layer. Yeah. So when you're commissioning these backbone links, make sure that the MTU is set to standard. Okay. Yeah, I think that's all. That's all we had for you in this ISIS refresher. And I will welcome any other questions in addition to the ones that we had along the presentation.
Sorry for opening the door. As a suggestion from your presentation between IS and OSPF, what is the weakness of OSPF that may lead us to implement IS? And is there any possibility to make a dual stack on routing protocols? I mean, surrounding of both IS and OSPF while phasing out at the end. At the end, I mean phasing out completely OSPF and leave it IS as a routing protocol.
Okay. Thanks. I think I can quickly take those questions. The first question is about the weaknesses of OSPF. I wouldn't say weaknesses, but maybe we can look at the advantages that come with IS. Like we said, if you have a dual stack network, you're running both IP version 4 and IP version 6. You notice that in OSPF, you have to configure basically two protocols, OSPF version 2 and version 3 for IP version 6. Okay, so that is a bit tedious. If you have a big backbone to work with and you have to create these two processes for OSPF, it's tedious to implement and also to troubleshoot. So with ISIS, this is all in one place. Okay, and the other benefit maybe will take us back to the inner workings of ISIS. In ISIS, there are just two LSPs. You have the level 1 LSP. The router will generate only one LSP, a level 1 LSP, or a level 2 LSP, depending on the level that you set your router to. But in OSPF, you have to know so many LSAs. Type 1 LSA, type 2 LSA, type 3 LSA, type 7, type 5, type 11 LSA. So for a person who is operating a network or managing a backbone, you want to keep your backbone simple, easy to troubleshoot. If there's a problem, you can quickly go in and resolve it. So imagine that you have to troubleshoot, understand all these 7 or more LSAs as they are in ISIS. It becomes a bit tedious. Okay. And again, like we said in the presentation, that designing the ISS backbone is not strict as it is with OSPF, where you require to have an area 0 defining your backbone and then attach all your non-backbone areas to the backbone area 0. And if you have an island or islands of the same area, you want those two islands to talk to each other, you have to create a virtual link with the backbone. So that is a lot of configuration, a lot of consideration to give to the design. In ISIS, you don't need to have a specific area. All you need to do is to have level 2s, just continuous string of level 2s, and those will form the backbone. You can have the same area attached to the backbone wherever and whenever. You don't need to create virtual links. Okay, yeah. Then the other question about whether it is possible to have ISIS work in parallel with OSPF as a migration, strategy. Joe, would you like to take that?
I haven't tried it. It's probably possible. I think if you enable ISIS on the interfaces and you have several interfaces connected to the same routers, you'll probably be able to bring up both protocols up. But it will be a nightmare, I think.
Yeah, certainly it will be, because now this takes us back. Sure. There's the concept of the administrative distance and route preference in Juniper, where a protocol with a lower route preference or a lower administrative distance in Cisco is preferred. So if you have ISIS running with OSPF, because OSPF has a lower administrative distance or a lower route preference, it will be preferred, regardless of the ISIS that is present in the backbone. So that means that you have to consider the route preference and make sure that, okay, you can set up your ISIS, you have a higher preference compared to OSPF. But then when you start the migration, you have to tweak your route preference such that certain parts of your network now prefer ISIS. Okay, so you really have to sit down and make a proper plan of how you're going to maybe increase the route preference for OSPF and in which phases. Yeah.
And then to have the connectivity, you probably now need to kind of import the routes into the other protocol and all that. And it's
sure.
That kind of distribution, it will be a nightmare. I wouldn't for experimentation, you can do it. But if you're doing it on a live network, I think you will not have a good time at all. It will just be better to manage your migration such that you switch it off, switch one protocol off, and bring up the network on the other protocol. That's
exactly.
the clean way of doing it.
Exactly. It's better that way, yeah, than managing both. Yeah. Any other questions?
There is one question from Olivia. Kindly clarify more on the multi-topology bit.
All right. So going back to the multi-topology, we say that IP version 6 can either run as a single topology IP version 6 implementation or a multi-topology IP version 6 implementation. Now, again, looking at the inner workings of ISIS, if you have a single topology IPv6 implementation, the router will run a single SPF calculation, meaning that when it's developing or creating the tree for IP version 6, it follows the SPF calculation of IP version 4. So if you have segments of your network that do not have IP version 6, okay, IPv6 traffic will be black hole. So for you to separate these two, you enable multi-topology ISIS, where you have separate SPF calculations or computations for one for IP version 4 and another one for IP version 6. Olivia, does that answer your question or?
Ibar, so level 1 and level 2 will, so if you have multiple area, if you're implementing a multiple area ISIS, that's when you need to mix level 1 and level 2s. If you have an area that has level 1, then the calculations for the SPF will be limited to that area. But in general, if you're running like a network like the one you're running, you can just do level 2 throughout to make it simple. You don't need to implement it in a multi kind of area implementation.
Sure. It's not required. So multi-area implementations, you may find them in enterprise networks, but for an ISP, it's not really required. It's not something that you'll find in ISP networks. All right, thank you all. Yeah, I'll stop sharing now.